Now let's look at how we'd find those other properties on the graph. Because remember, we're looking at a stress-strain graph. We're going to be able to find 5 properties. Young's modulus, which we've already done. Proportional limit, the yield stress, the ultimate stress, the fracture stress. So the first thing is we look at the proportional limit. What's the proportional limit? That is where the graph stops being linear. It's going to be in the linear elastic region, but it's right before the yield stress. And it looks like right about there is where it's going to stop. And so I'm going to say the proportional limit is about 490 megapascal. I'm just reading that right off the graph. 2% offset yield strength. So remember, this is our standard way of determining the yield strength. Why do we do this? Because especially as we look at this aluminum here, there's no easy way of seeing where the yield strength, where the elastic region ends. So standard way they do it for all the materials. How do we do it? We come here and we go to a strain of 0.2%. And so in decimal, this would be 0.002. And we draw a line with the same slope as the linear elastic line. So a line with slope E, same modulus elasticity. And what I do is I just look, where do they cross? The stress-strain graph is crossed by this 2% line right there. That is what we define as our yield stress. So in this case, we're just on the other side of 500, so we'll say the yield stress is 510. So once again, just reading it off the curve. Last two are pretty easy. Ultimate stress, what is the ultimate stress? Ultimate stress is right here. It's the most stress that a material can take. It's the highest value that we have on that. And so if I read over here, that ultimate stress is right about there. So we're going to say 775 megapascal. The last one's pretty easy too. It's a fracture stress. This guy right here, the fracture stress is where the bar finally fractures. And so we'll come over, just read it right over, and we'll say the fracture stress is 525 megapascals. So that's it. The most important one on here, though, actually, they're all important, but the most important one on here is this yield stress. Once again, we draw that line at 0.2% strain to mirror the linear elastic line. And so once we have those together, that's how we can find the rest of the properties for our material.